For a second, let's just forget about the engine. Today, we're going to look at your car's hidden brain, the one piece of software that you are literally trusting with your life every single second you're on the road. So I want to start with a question, and it's a question that's actually way more important than you might think. What's stopping a simple glitch in your Spotify playlist from, say, crashing your car's brakes? Now, it sounds dramatic, I know, but the stakes here are incredibly high. Well, the answer, it's a special piece of software. It's the unsung hero of your car, the automotive operating system. You can think of it as this invisible guardian angel for every modern vehicle out there. So what does this thing actually do? Well, the best way to picture it is as your car's secret and very, very strict orchestra conductor. Just think about it for a sec. A conductor doesn't actually play an instrument, right? Their whole job is to make sure every single musician plays the right note at the exact right time. And that's the OS. It doesn't control the brakes itself, but it makes darn sure the software that does control them runs perfectly and in complete harmony with everything else. Now, in the industry, this is often called the AUTOSAR OS. But don't worry about the jargon. The only thing you need to know is that this OS is built for just one purpose: safety and predictability. See, unlike your phone's OS, which is all about flexibility, this thing is designed to be rock solid and to never, ever be late. And that brings us to its first and maybe its most critical job: managing time with absolute, almost military-grade precision. Let's call it the unbreakable timetable. So here's the key thing to understand. In a car, being predictable is way more important than just being fast. Think of a Swiss train station, right? The OS makes sure that the check brakes train leaves the station at precisely 9 o'clock in 1 millisecond, and the update radio train leaves at 9 o'clock in 2 milliseconds. No delays, no exceptions. Ever. And here's kind of what that timetable looks like in the real world. This is a concept they call a schedule table. Now, at each tick of an internal clock, and we are talking about fractions of a second here, the OS triggers very specific actions. Like see here at tick 4, these two tasks have to run. Everything is planned out, right down to the millisecond, before you even start the car. But what if two tasks need to happen at the same time? Well, that's where priority comes in. The OS is programmed to know that checking the brakes is, infinitely more important than updating the GPS. So if both of them want to run at once, the brakes always go first. The GPS just has to wait its turn. This whole idea is called priority-based scheduling, and it is absolutely fundamental to your safety. Okay, so the OS is a master timekeeper. We get that. But what happens if a piece of software just goes rogue? Well, that brings us to its second major job: acting like Fort Knox for your car's code. The OS literally builds these impenetrable digital walls between all the different applications. It's like a security guard that ensures the media player, which is in a low security area, can never just wander into the high security vault where the engine controls are kept. And here's how it pulls that off. The OS basically divides all the software into two camps. You've got your trusted applications like engine control. They get a special key, and they can run in a privileged mode with access to all the critical hardware. But then you have non-trusted applications, like your media player. They get a visitor's pass. Their access is extremely restricted, and they are constantly being watched by the OS. Okay, let's watch this in action. Imagine your media player freezes up and starts hogging all the processor's attention. The OS, our security guard, detects this immediately. It triggers this internal safety mechanism called a protection hook, and it doesn't even hesitate. It just safely terminates that faulty app. And here's the crucial part. Yeah, your music might stop, but the engine, the brakes, the steering, they're all completely unaffected. The fault has been contained. So things get even crazier because modern cars don't just have one computer. They have several brains, or processor cores, all working at the same time. This means the OS has a third job, juggling all these different brains. Let's use another analogy for this one. Imagine the OS is like a really skilled diplomat at the UN. Each processor core is like a different country, busy with its own tasks. The OS is the one who makes sure they can all communicate and cooperate on shared goals, like, braking, without causing some kind of international incident. This diagram here really makes the point perfectly. So on the left, you've got one brain running the engine software. On the right, you've got another brain that's handling the dashboard. Now, they can't just talk to each other directly. That would be a huge security risk. Instead, they have to pass messages through the OS, which acts like a totally secure messenger. And that messenger service actually has a name. It's the Inter-OS Application Communicator, or IOC. Honestly, just think of it as the car's internal ultra-secure postal service. It is the only approved way for these isolated pieces of software to exchange information, which prevents a bug in one little area from taking down the whole system. Okay, so we have a timekeeper, a security guard, and a diplomat. Let's bring it all together and see how this symphony of safety performs in a real-world, life-or-death situation. So picture this. You're driving along, and the car in front of you just suddenly slams on its brakes. The automatic emergency braking system has to react in a fraction of a second. Okay, so let's break down how the OS makes this magic happen. First, the timekeeper. It guarantees the braking software runs at its exact high-priority millisecond. Second, the security guard. It makes sure that even if your map app just completely froze, it cannot possibly interfere. And third, the diplomat. It securely passes that brake now message from the sensor's processor core over to the core that controls the physical brakes. You see, all three jobs working in perfect concert. So I guess the real takeaway is this. The most important component in your car, it might not be the engine you can see. It might just be this invisible conductor, this automotive OS, that makes sure the incredibly complex symphony of software is always playing the right tune, especially when it matters most. I mean, all of this is part of a much bigger trend, right? Cars are just becoming these incredibly powerful computers on wheels. And that leaves us with a final question. What other invisible software systems do you think are out there keeping us safe every single day without us even knowing it? Let us know what you think in the comments. Thanks for watching, and we'll see you in the next explainer.